All right, so previously we established that the demand curve or market demand comes from individual consumers maximizing utility. So all that stuff we've been learning for the last couple of weeks, all that feeds into this idea of the market demand curve. And the demand curve itself represents maximum willingness to pay. So utility maximization establishes what we're willing to pay for products, and then what we're willing to pay for products establishes that market demand curve. And we can show some dynamics within the demand curve by shifting it based upon certain exogenous or endogenous shocks. A new study was performed on a product, and we find that it cures cancer, for example. That could cause a shift of the demand curve. Or we saw even something like the price of a complement good. This can cause the shift of the demand curve. We're going to talk about shifting demand curves and obviously shifting supply curves a lot more, but it's good to kind of go ahead and get that idea in your head, like what profits. Okay, this is going to be what dictates the producer decision-making process, right? Under consumers, the consumer problem was utility maximization. Under producers, their problem is profit maximization. In microeconomics, we refer to profits as the symbol for pi, and symbol for pi simply equals total revenue minus total cost, where total revenue is simply the amount of money I have coming in from the sale of my product. So that's just price times quantity. So what I'm selling my product for times how many of that product I sell, right? That's my total revenue. I simply subtract total cost from that. Total cost is going to be, we're going to call this average total cost for now. Don't worry too much about this, but just we're going to say average total cost times quantity is equal to total cost. Again, this will make more sense later on, but for now, just kind of, put this into your filing cabinet in your brain. Total cost is equal to average total cost times quantity. This is just the amount of money that I pay for my production. So all the labor units, all the capital units, all the things that I need to make my product, that's my total cost. So my profits are simply all the money I have coming in from the sale of my product minus all that I had going out. That is the cost of my product. And of course, my goal as the producer is to maximize profits. So I want to have total revenue as large as possible and total cost as small as possible. And so that's ultimately what defines the producer problem. It's to maximize profits. Okay, so here's a mathematical representation. On the horizontal here, we have quantity decision. So this is how much the firm chooses to make. And then here on the vertical axis, we have profits. So what we can notice here is that as the firm goes from producing 0 units to, say, producing 200 units, their profits rise fairly considerably. And then as they continue producing more all the way to 500, we see the profits are rising, and then they peak here at 500 units. So 500 units would be what we call our profit maximizing quantity. So under current market conditions, this firm should produce 500 units of the product because it maximizes their profits. Now, notice that we have that same increasing at a decreasing rate situation here that we had previously with utility. That is to say that, again, we have diminishing marginal returns. So as a firm produces more of their product, we do expect their profits to rise, assuming they sell those products. But at a certain point, even if they were to sell their products, the cost of production gets so high that, in fact, we expect profits to begin to fall. So the goal of the producer is not unlike the goal of the consumer. They are trying to maximize a particular value. Instead of utility, they're trying to maximize profits. So in this scenario, the producer would want to produce 500 units of the product. Anything less than 500 units and profits fall. Anything more than 500 units and profits were to fall. Now, the sort of question becomes, how does this occur? How are they able to get to this particular point? Well, they will think on the margin. As we've talked about before, optimizers think on the margin. Maximizing profits is the optimization problem for the producer. So in order to locate this number of units, the firm will think on the margin. The two marginal components that are important here are marginal cost, which is just the change in total cost divided by the change in quantity produced, and marginal revenue, which is the change in total revenue divided by the change in quantity sold. Now, ultimately, quantity produced and quantity sold are going to be the same thing. What is sold, the firm will, what is produced, the firm will hope to sell. Although technically speaking, cost comes from production, revenue comes from sales. We'll ultimately, again, say that they're the same, but it bears sort of repeating that they're slightly different. So the point is that we want to use marginal cost and marginal revenue to establish a rule. So let's think about it this way. Marginal revenue is the change in total revenue divided by the change in Q. This is just the market price of the product. This is just what you're selling your product for. Think about it. Your the change in total revenue divided by the change in Q. If this is just 1, then your total revenue changed by however much you sell your product for, right? So if I sell lemonade, for example, and I sell my 11th cup of lemonade, and my total revenue rose by $1, then that means I charged $1 for that 11th cup of lemonade. So marginal revenue is just the price that I sell my product for. When the price that I sell my product for, marginal revenue, is greater than marginal cost, that means that when I sell the next unit, my profits will go up because the amount of money I have coming in, the revenue, is greater than what I have going out in terms of cost. So I should produce more. So when my marginal revenue is greater than marginal cost, I should be producing more of the product. When marginal cost is greater than marginal revenue, this means that when I sell the next unit of the product, I will have more money lost than I brought in. So my profits are falling when marginal cost is greater than marginal revenue. So the goal is going to be to find where marginal revenue equals marginal cost. If you'll think back to previous part of the semester when we talked about using the marginal damage and marginal benefits of banning river miles for shipping to clean up a river that was being damaged with pollution, you'll remember that we wanted to find where marginal benefit equals marginal damage. Well, this is really no different, except instead of marginal benefit, we're talking about marginal revenue, and instead of marginal damage, we're talking about marginal cost. It's the exact same optimization principle, the equimarginal principle, again, thinking on the margin. So the firm maximizes profits mathematically by finding the production level where marginal revenue equals marginal cost. We can see this again on the graph. When marginal revenue is greater than marginal cost, my profits are rising, right? But when marginal cost is greater than marginal revenue, my profits are falling. So the goal is going to be to find this level of production, and this is where marginal revenue equals marginal cost, right here. Right? Marginal revenue is greater than marginal cost. My profits are rising. I should keep producing more. If marginal cost is greater than marginal revenue, my profits are falling. I should produce less. Therefore, profits are maximized where marginal revenue equals marginal cost. Again, it's just the first equimarginal principle that we've already discussed. Now, what happens when prices change? So we just established that marginal revenue is just the price of the product, right? So that means that the price of the product is greater than what it will cost me to produce the additional unit. This means that I should produce more of the product, right? Because my profits are rising. But if the amount that the next unit will cost me is greater than the price of the product, then that means my profits will fall. But what happens if my prices change? Right? This is what happens oftentimes in the context of markets. Prices will change. Well, this also changes my profit maximizing decision. So let's look at this example. Okay, so this example, we have a slightly different situation. Notice the numbers on the bottom here are different than the numbers here. And so again, we have 4 different profit outcomes, each of them with respect to different prices that I'm charging for my product. If I charge $5 for my product, my profit maximizing quantity is 50 units. If I charge $4 for my product, I notice that not only does this alter my profit structure, that my profits are now inherently less because I can only charge $4 where previously I was charging $5, but I also notice that my profit maximizing quantity falls. It was 50 units at $5 for my price. Now it's 40 units at $4 for my price. And this continues to fall as the price falls. Now this in some sense should be common sense. As I charge less for my product, my profit maximizing quantity will fall. Now, what's interesting about this is that students often get this exactly wrong. they think to themselves, well, if my prices are falling, this must mean that I need to sell more in order to make the same level of profits. But the problem is that this ignores the fact that since the price is below what it was previously anyway, I cannot simply sell an additional amount of products because my costs haven't changed, right? So from this profit function to this profit function, my costs are exactly the same. The only thing that's charged is that now every time I sell an additional unit of my product, I now get less in terms of marginal revenue, but my marginal costs have stayed exactly the same. So this puts downward pressure on my overall profits and actually reduces my profit maximizing quantity. So I notice that at a price of 3, my profit maximizing quantity is 30, and at a price of 2, my profit maximizing quantity is 20. And in fact, what I've just described is the behavior of the supply curve. As the price of the product falls, the willingness of the producer to supply to that market will also fall. Here's your supply curve. All right, here's your market supply curve. Okay, going back to the cereal example that we used to describe the demand curve from previous. The market demand curve is simply an aggregate of the individual supply curves, just like we saw previously with the demand curve, right? We have two different types of firms represented in this particular market, high-cost firms and low-cost firms. You'll notice that high-cost firms require higher prices relative to their quantity levels than do the low-cost firms, right? High-cost firms only provide 20 boxes of cereal at a price of $3.50, while low-cost firms will provide 45 boxes of cereals at that same $3.50 price. Now, generally speaking, this is how markets actually work. You have high-cost firms, you have low-cost firms, and in combination, we have our entire market supply curve. Again, we just horizontally sum the supply curves to generate the market supply curve. So at $3.50, high-cost firm produces 20 boxes. At $3.50, the low-cost firm produces 45 boxes, and then therefore the entire market, which is made up of high-cost and low-cost firms, will produce 65 boxes of cereal. This establishes our law of supply, which says that as the price of a product rises, the quantity supplied will also rise. The willingness of firms to supply to the market will rise. Notice that regardless of whether you're a high-cost firm or a low-cost firm, as the price rises, your quantity supplied, your willingness to supply will also rise. And your willingness to supply, just like utility maximization subject to a budget constraint for consumers, created optimal bundles, market prices and your cost structure will also produce optimal amounts of the product to produce. Notice that these profit functions are not just about what I can sell my product for, but they are what my product costs me to produce. So, as we can see, holding my cost constant, as prices fall, my willingness to supply the product will also fall. I can think about this the other way. Holding my cost constant, as prices rise, my willingness to supply to the market will also rise. That is the law of supply. All right, so just like the demand curve, we have supply shifts that cause the supply curve to shift to the right, which increases the supply, or shift back to the left, which is a decrease in supply. Sometimes students get this a little backwards because this looks like we're going up and this looks like we're going down, but just keep this in mind. An increase in cereal is a shift out and to the right, while a decrease in supply is a shift back into the left. That's, again, can be a little confusing, but just think about it in the context of hold a price constant, and then think about this. If my supply curve shifts out from this curve to this curve, at that same price, I'm now willing to supply more of the market. So at $1.50 at the original supply curve, it was a little bit less than 30, and then at $1.50 on the new supply curve, it's all the way out to 85. So this must mean that the supply curve increased. And the same thing for if it were to decrease. So let's look at 3.5. At 3.5, the original supply curve was 65. At 3.5, this new supply curve is only about 10 units. That must mean that supply decreased. Now, what causes shifts of the supply curve? This is almost always about cost of production. Basically, if your cost of production rises, then your supply will shift back, and if your cost of production goes down rather, then your supply curve will increase. The other thing that will cause a shift of the demand curve, and if we go back and we look at this, it will be if firms enter or exit the market. So if firms enter the market rather, then this is going to further push the supply curve out. So if we go back here, if, say, for example, in the cereal market, we had firms enter the market, then this would shift the supply curve out and to the right. If, on the other hand, and for some reason, we had firms exit the market, then this would shift the supply curve back and to the left. So regardless, we can now handle shifting the supply curve either out and increasing supply, or we can shift the supply curve back or decreasing supply. And notice, of course, here we actually have our demand curve, which we learned in the previous lecture, and we can see that we actually have the establishment of 3 equilibrium positions. Here is the initial equilibrium position, here's the equilibrium position when supply increases, and here is the equilibrium position when supply decreases. And we can see what happens to both price and quantity supplied and demanded when these prices change. Notice that when the supply curve shifts out, or an increase in supply, that the demand curve, of course, stays put because nothing has shifted the demand curve, but we move along the demand curve to a new lower price and a new higher quantity. On the other hand, if the supply curve were to decrease, we shift along the demand curve this way to a lower price, or excuse me, a higher price and a lower quantity. So now we can handle shifts in supply and demand. And again, I encourage you to check out the lecture notes where I really flesh out these shifts in a very robust manner. All right, and then again, here is just our equilibrium condition. This is the condition that is formed when I lay my supply curve and my demand curve on the same general framework. And I see that in this particular scenario, the equilibrium price is $3.50. And the equilibrium quantity is 65 units. We call this our market clearing price, and we call this our market clearing quantity. We call these market clearing because there is no unsold units at a price of 3.5 units. Notice that quantity supplied is 65 units, and quantity demand is also 65 units. So at a price of 3.5, there is neither a surplus of the product, nor is there a shortage of the product. If prices were above 3.5, we would see that quantity demand is greater than quantity supplied, and we call this a surplus. Again, if the price is above 3.5, we can see that demand is less than supply, quantity demand is less than quantity supply, and so we have a surplus. If price is below 3.5, we can see that quantity supplied is less than quantity demand, and so we have a shortage. At equilibrium, there is neither a surplus nor a shortage. That is why we call it the market clearing price and quantity.